In this section, we're looking at compound interest. So this is different from simple interest because simple interest only refers back to the initial deposit. You don't benefit from any of the future interest you've earned. So with compound interest, we're basically saying you get to gain interest on the interest that you've earned, which is a nice thing, right? Your money is working for you in essence. So we have this nice little formula here that tells us how to find the amount after T years, and we see some similar variables again. So the principal is P, the annual interest rate is R. We call this thing nominal just to say, well, yeah, by name it's annual, but really when we're compounding, the rate is always going to be larger than this. That works in your favor if you're investing. It works against you if we're talking about something like loans, which we will talk about. So let's start with a scenario wherein we have $5,000 deposited at 4% annual interest. I am pulling back the same information from the simple interest, mostly because I wanted to compare what happens with simple interest versus when we compound even quarterly. Quarterly would be 4 times a year or every 3 months. So once we find the answer here, we can maybe remind ourselves of what we got on the simple interest version of this, where we just compounded once at the end of the year. So we're going to use Excel to complete the table below using draggable formulas if possible. So I've already set this up for us, and we're basically just going to say, okay, well, my beginning balance on January 1st was 5,000. We're just going to copy that down for the beginning balance. We could say, really this is maybe the beginning of the day on April 1st, probably if we're talking about March 30th, something like that. So we're going to say, well, how much interest did I gain on that principal amount? Well, here's the part of, let me show you the formula again. Here's the part that's a little bit different. We have this variable m. We compound m times a year. In this case, m equals 4. So that's probably an important thing for us to have down here. So let me include that. Right, quarterly here, m equals 4. So when we look at what's happening here, this interest rate, it's taking our 0.04, our 4%, and it's saying, well, I'm going to split that up. So each time I compound, I'm really only applying 1% interest. But the thing is, we're doing that 4 times. So we're going to get, not only are we getting back to 4%, we're getting better than 4%. So the interest that we gain on the principal just at this first quarter, right? January to April is our 3 months, so 1 quarter. So we're going to say, okay, it's equal to our rate, which was 0.04, but we're dividing this into quarters. So again, that's the 0.04 divided by 4. So we're getting basically 1% of, meaning we multiply, 1% of this amount. So we get $50, which is pretty good. And then we say, all right, well, from there, we can take a look at the interest that we've gained on our interest. Well, since this is the first month, we actually don't have any, right? There was no previous interest that we gained, so we don't get to yet build up, but every future month we will now that we've gained some interest. So the total interest would just be the sum of these two cells. Now, for now, that's only $50, but in the future, that'll be a little bit more. So then we say, all right, great. What's my ending balance? Well, my ending balance is always just the beginning balance plus however much interest I gained. All right, so I know for sure, like ending balance, that one I can drag down because it's always just going to be, and let me click on one of these randomly, check in the formula bar, it'll tell me what it's adding. So it'll take my beginning balance, add my interest, that should be my ending balance. So again, it's always good to check those. Same thing with the total interest, we can drag that down. Right now those are going to say zeros, but if we check one of these, what is it doing? It's adding the 2 cells next to it. Great. Well, we have our ending balance is actually going to be the beginning balance for the next quarter. So we can just say equals this amount. And in fact, we could drag this one down as well. Right now, those values are just going to copy, but once we update the interest that we gain, then we'll be in good shape. So the interest on principal should be the same every time, right? The principal was the initial deposit. So really, this amount, now if I drag it, there's going to be a little bit of an issue there. It's going to change. I don't want that to change because the interest on the principal is a fixed amount. So every time we should have 50. So really what we're saying is we want to take the 0.04 divided by 4 and use our dollar signs to say it's a fixed reference, right? The principal stays the same. So this part should stay the same. So really the only thing we need to figure out is this: what is the interest on my interest? So this is saying, hey, we get to gain 1%, right? 0.04 divided by 4. We get to gain 1% on the principal, but we also get to gain that 1%, and I'm just writing it out as 0.04 over 4 because our rate could change and our number of compounds could change. But we get to gain that 1% also on the previous interest that we that we had gained. So we say, okay, well, I also had picked up this $50, so I'm going to get another 50 cents from that. So I get $50 from my principal this month, and then I get another 50 cents, 1% of this extra interest, right? My ending balance was $5,050, so I'm getting interest on both of those pieces. Then the next quarter, we basically do the same thing. We say, okay, I get interest from two different places, right? I get it from the initial amount that I deposited, the principal, and I get it from, well, my ending balance now is $5,150. So there's that extra $100.50 that I need to grab some interest on. Now, we want to turn this into a draggable formula. Originally, I used C3 because there was $50 here, but there was also $50 elsewhere. So maybe I want to turn this into something a little bit more reasonable, which is draggable, I should say. So why don't we take the ending balance and say, how different is that from the beginning balance, and not each month, but rather, again, that fixed beginning balance where we say I'm comparing it to my principal. So we still have 50 cents here. Let's drag this down. And it looks like we're picking up, right? Every month we're picking up a little bit over $50 in interest after this. So we pick up an additional 50 cents, an additional 50 cents, right, for each of those quarters. So at the end of the day, here's our ending balance. I'll bold that for us. So we had $5,203.02. When we did this with simple interest, we said the interest is P times R times T, so 5,000 times 0.04 times 1, because we looked at 1 year here. This said we would gain $200 in interest, so our total value would be $5,200, right? So compounding got us an extra $3.02. Compounding will always do better than simple interest. That's our first major lesson. But all right, that table is complicated. We don't want to do that every time. We'd have to change a ton of elements of that if we're compounding weekly or daily or monthly, so we don't have to go through that every time. It's not impossible, but I'm going to let us use a template here so we don't really have to copy that information. So the template is actually in the same place. Sorry, let me get that into view here. It's in the same file as the simple interest. It's just a different sheet down here at the bottom, a different page. So we can click on that. Now there's a couple different things you can do. You can you could give a bunch of information and figure out what we just did, which is how much interest did we earn and what's the total value. Or we might want to solve for the present value. We might want to say, hey, I know what I want to have in the future. What do I have to deposit right now to make that happen? So this template's going to be pretty useful in that regard. Okay, so let's apply it. Suppose you've got $3,000 deposited at 1% annual interest. Interest is going to be compounded monthly. So again, this was in our formula, this monthly compound is basically saying M, the number of compounds per year, is 12. So let's open up our template here, and it would be wise, I think, to kind of work along with this as I'm showing it. I'm going to kind of keep it in view so we can see this other info. Okay, so our principal, what did we deposit? 3,000. Our annual rate, R, and I tried to use the variables that we kind of refer to in the formula, even though, again, you have this template here. So you can enter this as a percent or a decimal. So we either need to do 0.01 or we need to say 1 with the percent symbol and it'll just convert it to 0.01. If we just say 1, it's going to think it's a decimal. It's going to say 100%. So we definitely don't want that. So 1% or 0.01. We've got 12 compounds a year. And then let's see, we've got to figure out a time in years. So what does this want us to do? How much is in the account at the end of 1 month, 1 year, and 5 years? Well, the second and third parts of this are pretty easy, right? 1 year is just t equals 1. 5 years, t equals 5. We've seen this before with the simple interest. 1 month, well, t is not going to be 1 because that's what we have in part B. That's 1 year. So we're going to do 1 out of 12, right? 1 month is 1/12 of a year. So let's see. And we want to know a couple different things. How much is in the account? How much is in the account? And then, how much interest? So just be careful with those. So let's start with the first part. So let's say, okay, this is equal to 1 out of 12. And remember, we do that depending on the settings here. It might not show up as in the format you want. You can always change that. No big deal. So if we do this, if we deposit our $3,000 with all those conditions, then we have a total value at the end of this of $3,002.50. So $3,002.50. Right? So that means in that 1 month we gained $2.50 of interest. It's not great, but again, interest is like free money, so I'll take it. Right? If we change this, if we say, okay, instead I'm looking 1 year later, so not 1 month, but 1 year, then we see that we're up to $3,030.14. Now, the homework questions might ask you to round to the nearest dollar or something like that. In general, I'll ask you to round to the nearest cent. I'm interested to know, just how different these things are. Okay, and then in part C, we're asked about the interest after 5 years. So we're going to change the time to 5, right? All the other parameters stay the same. But now I'm not interested in the ending value, the total value. I want just the interest earned, which is $153.75. And so this is where the template is really helpful because we can just toss everything in there. Okay, let's suppose you've got $12,000, and I'm going to, again, pull this up, keep it in view. So we've got $12,000. That's our principal, or our present value, PV. Our annual rate is going to be 2.4. So again, if you just want to do 2.4% and let Excel take care of it, and in this case, right, it says 0.02. Of course, if I just alter, let me just add a decimal place, right, then we're going to see what we need to see. Okay, then we've got, we want to know how much is in the account 8 years later, so T equals 8. And then we're going to change the compounds, how frequently we compound. So let's start with that. So compounding annually, that means M is 1. We just compound once at the end of every year. Monthly, M is 12. And daily, M is, let's call it 365, right? Some years are going to have 366, but let's just do 365. Okay, so we're just going to change these values. So we're going to say compounds per year. Here's the first one, 1. And we're finding how much is in the account. So we're looking for the very last value. So 14,507.11. For the first one. If I change that to 12 compounds per year, we got 14,537.26. So that's about $30 more just by compounding more frequently. And then if we compound daily, so 365 for our compounds per year, we have 14,539.95. Not as much payoff at that point, right? So there was a $30 jump from annual to monthly, but only like a, roughly $2.5, $3 jump from monthly to daily. So there are sort of some diminishing returns here. So most of the time we're going to deal with monthly, but we will check in on some of those other values. I'm going to make another video where we, use the template a little bit more and work backwards as well.